So our next talk is applying ephemerality to cloud access management with your speakers, Chonhui Zhang and Divya Dwarkanath. Please give them a warm welcome.
Hello, everyone. Welcome to today's session. So I'm Qian Hui, and I have been in Snap for 2 years as a software engineer in data security team right after I graduated from college. So in the team, I have been working on internal tools that provide access management control on tons of services and engineers throughout the company. And this is Divya.
Hi, I'm Divya. I've been at Snap for about 5 years, and I've spent pretty much the entire time working on application security. Last 2 years or so, I've been running the same team. Prior to Snap, I used to be a security consultant, and I did pen testing engagements and security engagements for a bunch of companies in the Bay Area. So welcome to the cloud. So for the last 8 years that Snap has been around, we've been heavily reliant on Google Cloud Platform to support our infrastructure needs for both our mobile user traffic as well as internal tools and web apps that we build. In the last year or two, we've increased our AWS presence by a lot, and we are truly in a multi-cloud infrastructure space. Both these platforms offer lots of benefits, both in terms of engineering and security, and we work with them to make feature requests that could help us with our specific needs. But we also needed to customize the way we manage access to both of these cloud environments, specifically related to role-based access control. And we took the concept of ephemerality and delete by default that we love so much as a Snapchat concept and tried to apply it to cloud access. Like I said before, we use both AWS and GCP, and we have tens of thousands, maybe more resources in both these cloud environments. For simplicity's sake, resources, anything that you can attach a set of permissions to. And typically a software engineer needs access to these resources for a variety of things like deploying code, debugging, viewing logs, looking at the data that they've just written into a database, etc. And they go about their day by running into a bunch of roadblocks and permission errors, and they figure out what they need to do to unblock themselves. And one of these activities is to get permissions on all of these resources. So they ask people around them, ask the rest of the company and the team, etc., and they unblock themselves. A lot of times, we wouldn't know what access we need, so we just do a trial and error process to get that access. So it's an iterative process which involves lots of decision making and randomness. So I may think I need these list of permissions, and then some more. At the end of the day, I get my job done. I have all these permissions, most of which I don't need. But then I don't want to do the same thing tomorrow because I've bothered half the company trying to get them. So I come up with the brilliant idea of getting owner, editor, viewer access to every project that I know about, or getting whitelisted for a role that has all kinds of access on Amazon. So this is a really bad idea because there's no concept of centralized access management or access management or role-based access control, and I can't enforce fine-grained permissions on any of the cloud resources. Cleanup is challenging, so if an owner of a resource is trying to trim all the permissions, they look at all the accounts and they don't actually know which of these they need to keep around, which they can remove. And unlike service account usage, it's really hard to look at find the usage patterns for an individual user. Auditing monitoring is really hard. So a good example of this is when my team does red teaming engagements. At the end of the engagement, if we find something cool, we want to go back and look at all the sequence of events that happened before we exploited a classy bug. But we don't have that data, and we have to go through loads of event logs or manually track everything we do. And finally, if my credentials are compromised, an attacker who has those credentials has a lot of permissions given to them on a platter. They don't have to do anything special to escalate privileges or phish other people, etc.
So in order to solve this, we built LeaseTool, a centralized platform to manage the permissions on both GCP and AWS. And with this new model, any direct IAM set in the console will be denied and rolled back by LeaseTool. So the only way to get authorized access is through LeaseTool. In this way, we keep LeaseTool as the single source of truth in terms of permission governance. So let's take a look how LeaseTool does its work. Imagine if I just signed a ticket to fix a bug. So probably I need to go to the stack driver to see the logs in order to figure out what is going on. So I come to LeaseTool, say, I want log viewer role on this project A. Along with my request, I'm also required to put the appropriate justification in order to let the resource admin to decide whether to approve or reject my request. It is also used for auditing purposes, just in case the compliance team might need to take a look in the future in case there is anything suspicious. We also created a concept called short-lived leases, which will create a temporary access. And we will come into this part in detail in the following slide. So let's see. Lucky enough, I got approved by the resource admin, so I can get access and continue with my debugging work. So how does this short-lived lease work, and what is lease capability? So lease is a time-bounded or ephemeral access on a resource. And the lease capability is a signed contract between user and resource admin to say when and how long this user can maintain access. Lease capability also has a lease length, as you can see, as well as an expiration date attached to itself. So at the time when the lease request is being approved by the resource admin, this user will gain a lease capability. Let's say probably good for 1 month, and a appropriate lease length, maybe 10 hours. Then with this valid lease capability, so for the whole month, this user is able to create a lease at any time to gain a temporary access, which is bounded by the lease length, is 10 hours for this case. And after 10 hours, this temporary access will be revoked. So you may also notice that this model does not really fit to service account because they are not human. They cannot go to the tool to say, I want access on resource ABC. So we created another concept called whitelist for service account usage. And the request flow is pretty similar as lease request. It will be sent out by user. The only difference in a whitelist request is that user needs to specify the service account ID that will have this access. And the access could be either time-bounded or permanent, depends on how this service account will be used. Also, with LeaseTool, it's pretty easy to clean up the unused permissions for a service account if there is anything misconfigured. So for this time-bounded lease and whitelist, how do we make sure the access is actually invalidated after they expire? And how do we enforce the permissions that is being set up directly in the console by resource owner will be rolled back properly? LeaseTool achieves this by running some background jobs. So each time when a job is triggered, it will pull the current policy snapshot on the tool for each individual resource. and comparing it to the policy in the cloud, overwrite anything that is different. So let's take an example. For example, if I want to set up a pipeline which backs up data from spanner table to a GCS bucket, and I also happen to got a project owner on my project. So I just want to do the simple thing, like I go to the console directly, and on the IAM page, I grant the service count, which runs this pipeline, the spanner table read, and the GCS bucket write role. So I saw everything set up, but it turns out that my pipeline will finally end up with false read because all the permission I set up will be overwritten or rolled back by the list tool. So in this case, we make sure list tool is the single source of truth for the permission management. Also, for contractors, they need to go through an extra compliance review before they can access the tool, so that we make sure their access is meet our compliance requirements. We also integrate report card into list tool to make sure all the COP machines meet our security standard before they can have prod access. So if your report card status is failing for some reason, and we will block you from accessing list tool, which in turn you will also you will also don't have any access to the to any of the resources. So in order to unblock yourself, you need to fix the report card first. We cooperate with COPSEC team to integrate this feature so that it helps us restrict the prod access from insecure devices. We also in turn help them to patch, to drive the patches on the COP machines. Following is some blocking reasons that you won't be able to access this tool, like lacking of critical OS update, or antivirus is not running on your laptop, even like we detect any malware is running on your device. As a permission management tool, this tool also supports permission revocation. So let's say if your laptop is stolen, you just need to shoot an email to Snap. Someone will can revoke your access with just one click. Similarly, user can also revoke the access by themselves if they feel they have way too much access that they need. So having been talked about all the conceptual meanings, let's take a deep look at the implementation detail. So for GCS resources, we mainly use two APIs. We first get all the grantable roles from Google and record the list in a format of in a combination of resource, account, and role. Then we set IAM policy based on the current snapshot on the list tool. For AWS resources, the flow works similarly as GCP from a user's perspective, but from an implementation standpoint, there's a couple differences. We need to store all Snap Eng users in one AWS account. We also need to create all predefined roles by ourselves and making them trust above AWS account. Lastly, instead of updating the IAM based on a resource basis, we need to update users' permission policy.
So with the list tool, we now have a way to do role-based access control and manage access in one place. Let's take a look at what administrative activities we implemented for approvals and policy setting. So resources ultimately contain data of some kind, and we want to make sure that the sensitive resources have more tighter access controls and monitoring. For things we care most about, like private media, we already have end-to-end encrypted one-to-one snaps, and we are working on extending that feature to multi-snaps as well as chat media. For PII such as location, email, phone number, etc. Our privacy engineering team built a tool called Data Mapper that goes through all the cloud resources and tries to do probabilistic detection of PII within them. And when we find PII and we have categorized sensitive resources, we make sure that they are completely out of bounds for individual accounts. But in order for several features to function, you need service accounts to be attached to these resources. In those cases, we have an explicit approval process, and the security team attaches a policy for these service accounts in the lease tool. We also have requirements around heavier resource administration, and there's a lot more auditing and monitoring for anything that touches these sensitive resources. For all the non-sensitive resources, the security team did not want to be a bottleneck for looking at every single request and approving them, because A, we don't have context. It takes a while to figure out what the context of the access is, and we would rather be just doing engineering work. So we decided to crowdsource the administration. An engineer who creates, let's say, an S3 bucket is now responsible for administering, creating policies, governing, and going through access once in a while and auditing that this is as expected. They can also share the administration load with people on the team who really understand how these resources are supposed to be consumed. So to summarize, we've created a centralized access management solution to manage our multi-cloud infrastructure, IAM, and roles. We are able to do administration activities in one place and have visibility over all resources and all the permissions attached to them. We've also forced developers to think about what access they actually need and make good decisions based on that. And we also introduced a concept of time-bound access called leases. Last but not the least, we have one place to set up policies and comply with our internal security requirements.
So the deployment of those services actually faced some challenges, and we also learned a couple lessons. First of all, the initial rollout is always challenging. So because we are asking engineers to significantly change the way how they set up and build their service, so we had to make several modifications along the way. And one of the examples that we have when we were trying to manage a GCS bucket in LeasePool, we built out all the features like create and delete bucket and manage permissions on the LeasePool. As part of the rollout plan, we also need to migrate all existing buckets that is in the company into LeasePool, and also to enforce the policy across the board. So we communicated with different teams, but got some feedback that this actually will break some of their current workflow. So the reason is that they have some automation pipeline which will create a temporary service count on the fly and grant the permission to a GCS bucket to some data transferring. So if we turn on the enforcing mode in the LeasePool, so the cron job in the LeasePool will basically wipe out all the permissions that is set up in their pipeline directly. So we need to, so we worked with them to make some changes. Basically, we provide a GCS IAM update API through LeasePool to them. Instead of doing the IAM update directly in their pipeline, they call LeasePool to do the job for them. So in this way, we still make sure LeasePool is the only source of truth who can manage the permissions. Another big challenge we have is the guidance on IAM roles and policies. As a developer, usually for those outside of security team, they probably don't know much about access control and what is the best practice to achieve the least privilege principle. Their first priority might be get their job done and launch the feature as soon as possible, which is fair enough from a product perspective. So instead of spending time to figure out what are exact permissions they need to request, so they probably will think, why not I just get an editor role, which has a superset of permissions that I need. So we try to come up with some frequently used roles that people may need for some common use cases, and offering those like recommendation or support through Slack and also internal Stack Overflow. We even built some cool features like list suggestions. So basically, we collect all the list requests that your teammates are requesting and provide them to you as a recommendation. Also, the on-call lists. So we automate some of the permission granting to the on-call person in the team. And each team can specify a bunch of resource permissions that their on-call might need during the on-call job, so that whoever is on call for this team will have those permissions automatically. So this is actually really helpful for those emergency cases. Last feature is historical access, so which is my favorite feature because I use it a lot when I was trying to get access. So it will list out all the access you have requested for the past whole week. So that I just need to click a checkbox to say I want to do a batch request for all the permissions done. So it saves me a lot of time and effort. So this challenge is not a solved problem. What we were trying to do is to make people think more actively about the access they need and try to make them so that they can make some decisions. Also, as we switch from monolith to microservice model, we also need to rethink about some of our strategy. Like for those non-sensitive resources, maybe we can do auto-approving so that they can save the time waiting the approval from the resource admin. We can also increase the default list length, which may reduce the frequency that they go back to list to request again. So that's all about our today's presentation, and thank you for listening. And one more last thing is we are hiring. Thank you.